a region scientists have long considered forbidden, not because of any law or legend, but because of the extraordinary dangers and mysteries it conceals. When a recent scientific expedition finally breached this icy frontier, what they uncovered beneath the frozen crust would challenge our very understanding of Earth's past and the forces shaping its future. What they found was not just unexpected, it was almost impossible. Before we start, hit the like and subscribe buttons for more updates. The discovery began in an area of East Antarctica known for its towering ice cliffs and massive crevasse systems that make access nearly impossible. Satellite imagery had long hinted at unusual thermal readings coming from beneath the ice, a subtle yet persistent anomaly that refused to align with known geothermal patterns. For years, experts debated whether it was an error in instrumentation or the sign of something extraordinary hidden far below. Then, during an ambitious multinational research initiative using advanced ice-penetrating radar, the truth began to emerge. A hidden void miles beneath the ice appeared on the radar unlike anything scientists had ever seen. When they managed to send a probe down, it transmitted data that left researchers speechless. Beneath more than 2 miles of solid ice, they found an enormous cavern filled not with lifeless rock or solid frost, but with a body of liquid water. An underground lake sealed away for millions of years. Its waters, warmed slightly by geothermal energy from Earth's crust, had been completely isolated from the surface since before humans even existed. This alone would have been a monumental discovery. But the most shocking revelation came when biological samples were taken. Inside this alien ecosystem, scientists detected microbial life, organisms thriving in total darkness, extreme pressure, and near-freezing temperatures. They were unlike any life forms cataloged on Earth's surface. Their genetic makeup bore markers so distinct that some researchers speculated they represented an entirely unknown branch of life. As analysis continued, further samples revealed complex organic compounds, chains, and structures that implied not only adaptation, but possibly ancient evolution in isolation. These microscopic entities had survived and even flourished in conditions once thought absolutely sterile. Their cell membranes exhibited biochemical mechanisms resistant to radiation, salinity, and cold far beyond the known limits of extreophiles. The implication was staggering. Life could endure and perhaps originate in environments far harsher than anyone imagined. This immediately drew comparisons to Europa and Enceladus, the icy moons of Jupiter and Saturn, which harbor subsurface oceans beneath frozen crusts. If life could exist under Antarctica's ice, similar processes could easily unfold on those distant worlds. But the intrigue did not end with biology. As sensors mapped deeper into the cavern system, they discovered vast deposits of mineral formations that could not have developed without prolonged hydrothermal activity. This suggested the region was once geologically active, perhaps even part of an ancient ecosystem before being entombed in ice. Some mineral patterns resembled those formed by microbial mats on the ocean floor, leading geochemists to theorize that the subterranean lake might be a remnant of a prehistoric sea trapped when the continent froze over 34 million years ago. The isotopic ratios in the water supported this theory. It wasn't purely glacial meltwater, but contained chemical traces linked to ancient marine environments. Even more unsettling was the detection of faint magnetic fluctuations beneath the cavern floor. These anomalies indicated the presence of metallic concentrations or a deep geological structure unlike anything nearby. When researchers deployed magnetometers and seismic instruments, the data revealed a symmetrical circular formation buried deep within the bedrock. Its precision and shape confounded expectations. Natural formations rarely exhibit such perfection. Some geologists cautiously proposed it might be a massive impact structure, a crater from a meteorite collision so ancient that its features had long since been masked by ice and tectonic motion. If confirmed, it could rewrite parts of Earth's geological record, possibly even correlating with extinction events in prehistory. The deeper the expedition probed, the stranger the results became. High-resolution imagery revealed faint heat signatures emanating from fissures below the cavern floor. These emissions were inconsistent with the expected geothermal gradient, suggesting localized hotspots or venting of unknown origin. When thermal sensors were lowered, they detected oscillating temperature patterns, hinting at dynamic processes still occurring beneath the ice. This baffled geophysicists. Such rhythmic fluctuations could indicate liquid movement or even subsurface activity resembling volcanic plumes. The idea that Antarctica, long considered geologically dormant, might still harbor active subterranean heat sources, sparked intense debate. During one of the final phases of exploration, a robotic probe equipped with cameras managed to capture footage that would send shock waves through the scientific world. The images showed not only the shimmering walls of mineral ice and crystal formations, but also strange filamentous structures embedded within the cavern surfaces. These were not geological artifacts. They appeared organic, almost like fossilized remnants of microbial colonies. Some strands pulsed faintly under infrared illumination, hinting at metabolic activity. For days, scientists reviewed the footage in disbelief. Could these be remnants of an ancient biosphere or evidence of ongoing life, forms unlike anything previously seen? Further analysis of the organic material revealed protein sequences that bore no direct relation to modern organisms. The amino acid patterns were unusually symmetrical, and their molecular chirality defied standard biological conventions. It was as if nature, isolated for millions of years, had taken a different evolutionary path entirely. The discovery forced biologists to reconsider long-held definitions of life itself. If these organisms were truly unique, it would mean that evolution could independently craft complex biochemistry in complete isolation. This realization had profound implications, not just for understanding Earth's history, but for the search for life throughout the cosmos. As word of the discovery spread through the scientific community, new questions arose about the Forbidden Zone itself. Why had this region remained so inaccessible for so long? The truth lay in its extreme conditions. Hurricane-force katabatic winds, shifting ice shelves, and treacherous subglacial creases made it one of the most dangerous places on the planet. Previous expeditions had been thwarted by equipment failure and severe storms. Only with the latest generation of autonomous drilling technologies and satellite guidance could scientists even attempt to reach it safely. The secrecy surrounding the project stemmed partly from environmental concerns. Disturbing an untouched ecosystem could risk contamination both ways. But now, with data in hand, researchers faced a dilemma. How much of this new world should they explore further? And at what cost? The implications of this hidden biosphere extend far beyond mere curiosity. If such life can persist without sunlight, relying solely on chemical and geothermal energy, it demonstrates that the boundaries of habitability are far wider than assumed. This transforms how we think about early Earth. Perhaps life first emerged in environments like this, deep underground, shielded from cosmic radiation and climatic instability. The Antarctic microbes may represent a living snapshot of primordial conditions, offering clues to how the first cells adapted and survived in an unforgiving world. By studying them, scientists hope to trace biochemical pathways that could reveal the very origins of metabolism. Geologists, meanwhile, are fixated on the structural anomalies beneath the cavern. The circular formation identified by seismic readings bears characteristics of both impact and artificial symmetry. Its diameter spans nearly 20 m, and its composition includes metallic elements uncommon in Antarctic crust. Some hypothesized that it might be a massive iron-rich core from an ancient asteroid that struck the continent when it was still forested and temperate. If so, the energy released would have altered global climates, perhaps triggering glaciation that led to the very ice now concealing it. Others entertain more speculative notions that the formation may not be entirely natural, that it could hint at unknown geological processes or even remnants of something constructed long before humanity existed. The magnetic anomalies surrounding the site add another layer of mystery. Instruments recorded periodic pulses emanating from deep within the structure regular enough to raise eyebrows among physicists. While natural explanations, such as piezoelectric effects or magnetic resonance in iron deposits, are plausible, the rhythm of the pulses was unusually consistent. Some researchers have cautiously described them as artificial seeming, though they stopped short of making sensational claims. The mere possibility that the signal patterns might not be random continues to stir debate among experts. some of whom have suggested further investigation using neutrino detectors or gravitational sensors. Another extraordinary element of the discovery lies in the water chemistry itself. Samples from the subglacial lake showed unexpected ratios of noble gases and isotopes, suggesting that the environment had interacted with Earth's atmosphere at a time when oxygen levels were far lower than today. This means the lake had been sealed since before major evolutionary transitions, before plants oxygenated the air, before the great diversification of life. Within this isolated vault, evolution took a divergent route, shaped by pressures and energies alien to modern ecosystems. The discovery effectively gives humanity a window into Earth's deep past, preserved in pristine isolation. Meanwhile, glaciologists studying the region's ice layers found embedded dust particles containing micrometeorites, offering hints about the cosmic environment when the continent froze. These particles matched compositions found in asteroid belts, suggesting that Antarctica's ice acts as a chronological archive of interstellar events. The deeper the samples, the older the stories they tell. Combined with the mysterious subsurface anomalies, this paints a portrait of Antarctica not as a dead, frozen wasteland, but as a living geological time capsule, one that may contain secrets of planetary evolution stretching back hundreds of millions of years. The environmental implications are profound. If geothermal heat pockets exist beneath the ice, they could accelerate melting from below, contributing to instability and massive ice sheets.